definitely the evening now, and I'm the penultimate talk, so I won't hold you too long, I hope. A whiskey party. I was hoping just for beer. Maybe I'll find a beer later. Anyway, I hope you've enjoyed the conference so far. This is the second of 3 talks I'm giving this weekend. And this talk is mostly about me getting old. It is about confusion in the land of the serverless. This is me trying to make sense of what serverless means to me, and what it makes sense to everybody, really. I've written a book about microservices. It doesn't include serverless in it anywhere. That's how dated my book is. It only came out 2 years ago, and it's very depressing. And I also run my own company, which I mentioned before. But this year has actually been a really big year for me, personally. I mean, I am the center of my own universe, so I've been doing a lot of thinking about myself, how important I am to myself. The reason it's a big year for me is because, not just setting up my own company and all those things, the reason it's a big year for me is because I feel like I'm getting quite old, like really old. I'm now 40. I make sounds when I sit down in a chair. I make more sounds when I have to get out of the chair. As Louis C.K. once said, getting out of a chair is the worst part of my day. Why do I have to get up? Can't somebody else do something for me? My back hurts. You know, these things happen, right? You get older, you get wiser. Hopefully we get wiser, but also we get a bit more confused. I mean, to put things into perspective, my first programming language was Fortran 77, which is the programming language that was created in the year of my birth. So I coded in Fortran 77, a language which is still constrained by the limitations of punch cards. I remember when the internet came on a floppy disk. I still remember when I got my first 14.4K modem, and rather than the images downloading like this, they downloaded like that instead. It was fantastic. A lot of you don't remember that, do you? That's quite sad. You know, when someone would pick up the phone and you'd have to put it down again because the internet stopped working. I remember when Facebook was the Facebook. I still insist on calling it the Facebook. I'm not on the Facebook because I find the whole thing a bit too daunting and confusing. Equally, I don't engage with the Snapchat either. I don't really understand what Snapchat is. All I know is that occasionally my stepson will take out his phone and go, and then take a photograph of it and send it to somebody else. And then I said, well, what happens? Well, it just the image, and they look at it, and then it vanishes. And it's like, well, I don't understand what's happening with the world. But I'm not that much of a fuddy-duddy. I don't like you to think that I'm not cutting edge and down with the kids and all that sort of stuff. When it comes to serverless computing and cloud computing technology in general, I've been using this stuff for quite a long time. Many years ago, I started working with Amazon Web Services, I suppose, back in about 2008, 2009. I ended up creating some of the first training courses for it all the way back then, back when Amazon didn't really care how you used it as long as you gave them money. And so it was all the fun time, an exciting time. But now, of course, the offerings out there have exploded, and I find myself constantly asking myself the question, which is, what on earth is going on? I've even got a badge with my name on it in case I forget. And specifically, like, what is going on with this whole serverless stuff, right? What's going on with that? I'm actually going to get rid of this badge now. Look at this. It's like an old man stumbling around on stage. Here we go, hashtag serverless. It's all got to be serverless now. It's the hip new trend, serverless computing. And we can tell it's the hip new trend because we can check it on the Gartner hype cycle. Here we are. You can see my own specialist field of interest, microservices, are riding high right now. But oh look, coming up on the outside lane, it's serverless. Soon to push my own specialism deep into the trough of disillusionment, where all technologies are crushed under the jackboots of enterprise vendor technology, and all the cool kids move on to the next thing. So I'm obviously worried about this. You know, I now make a living doing this sort of stuff, so I've got to keep an eye on what's happening here. But of course, the first thing I react to is the name serverless and what that means. Serverless, no servers. But of course, we all know there are servers out there. We are computers out there. So what really does this term even mean? So I started poking around, trying to understand what serverless meant, and really where the term had come from. I'm always quite fascinated by how terms emerge and how they change. In my keynote tomorrow, I'm going to be talking about where the term microservices came from, for example. So, where did the term serverless come from? Turns out the term's been around with us for quite a long time. The first article on this by Ken Fromm was actually back in 2012. This is the first citation that I've found so far for the term serverless. So it's a 5-year-old term whose time has come. And in his article, Ken is trying to sort of look at the emerging cloud services that are coming up and trying to encapsulate what it is that's making them a bit different to what came before. There's a nice phrase from this article. The phrase serverless doesn't mean servers are no longer involved. It simply means that developers no longer have to think that much about them. Computing resources get used as services without having to manage around physical capacities or limits. So it's about abstraction. That's all serverless is. It's just about abstraction. It's about hiding the underlying computers from us. Now, the reason I'm kind of interested in where this term came from is also because of how we talk about serverless now. You talk to some people, and they say, serverless is functions, serverless is Lambda. But Lambda launched in 2014, and really wasn't that usable for many people for quite a while. So 2014, so there's definitely post-serverless is Lambda. It's just one of a bunch of things. We also have to recognize that what serverless is varies. And the concept of serverless is very much in the eye of the beholder. For those of us using these wonderful platforms and thinking, oh, isn't it great? It's just a function. I don't have to worry about it. I only pay for what I have to manage. And sometimes it's easy for us to forget that there is some poor person or people underneath handling all of this stuff and going, what on earth is going on? Now, increasingly, these people are not our people. They're not people we employ. We give money to Amazon and Google, and they have this stuff run for us. But we should remember that serverless, as in any abstraction, is purely in the eye of the beholder. It's great to us, but there's still real machines running underneath all this. The question is, how leaky is that abstraction? So I thought, okay, well, Lambda gets talked about as being synonymous with serverless, but serverless is clearly more than just functions as a service. So what is it? An old colleague of mine, Mike Roberts, actually recently wrote a really good sort of in-depth piece on serverless architectures, which is actually published over at Martin Fowler's site. And so he goes really in-depth into what serverless means to him, different types of architectures, and I can thoroughly recommend this article. But I was talking to Mike recently, and I was trying to say, well, what is it that for you makes something serverless? What are the criteria that for you define a good serverless offering? And so he came back with these sort of 5 points of what makes serverless. So here's definition. The very first thing is no management of server hosts or server processes. So I'm not saying I want 5 of these or 10 of these or 6 of these. The platform should just work that stuff out for me based on what I ask for. The platform should auto-scale and auto-provision based on load. So scale up, scale down. I don't care about that. Cost based on precise usage. This is what's got so many people excited about some of the function as a service offerings, for example. You're only paid when your function is invoked. If your function isn't being used, it's not running, you're not being charged. Also, the performance capabilities are defined in terms other than host size or count. So I'm not saying I want 5, I'm just sorting it out. And implicitly, that you have some concept of high availability. So there's the idea here that a lot of the resiliency concerns are out of your hands. And I say that differently. It's not that you don't have to worry about them, it's that you have no control over them. So you really do have to trust the underlying platform when it comes to resiliency, high availability, and the like. So based on Mike's definition, you can take a look at some of the cloud offerings out there. You can obviously, functions as a service like Lambda or Azure Cloud Functions fit Mike's definition. I'm not worried about processes or invocation counts. I'm just saying, here's my code, launch it and run it as you like. But equally, backends as a service, like Google's Bigtable or DynamoDB on AWS, they absolutely also fit that definition of serverless. Because with those, you're not provisioning a database instance. You're just saying, store my data. Now, those of you who have used these sorts of storage systems know that there are challenges sometimes in terms of how effectively and efficiently they scale up or scale down, but nonetheless, they fit that definition of what serverless is. I'm not worrying about precise hosts and things like that. So I started thinking more widely about the cloud platforms that I really love, that I think are fantastic. My gold standard from a developer experience for a platform as a service is still Heroku. I still think it's fantastic, excellent service. It's a bit expensive, but my general advice, if I talk to a startup and they say, we're going to think of Kubernetes or something to run. No, if you're a startup, stick it on Heroku. Simple, easy, but Heroku has the concept of pods. Well, not pods, but dynamos and workers. You are still dealing at that concept of servers. You're still not serverless based on Mike's definition. Okay, so Heroku's fantastic, but not serverless. Okay, does that mean I can't use it? Oh, I don't know. Let's look at other things that are serverless based on those criteria. Salesforce.com. Anybody here developing for Salesforce? Working with Apex? Yeah. You guys are serverless, rock on. Right? It's not sexy, right? But it is serverless. You're just deploying your Apex functions or your Java code onto Salesforce. You're not worried about server processes. We can argue about whether or not you're being charged based on exact usage, but you'll have to talk to your enterprise vendor for conversations about that. What else fits? Fastly, it's just a content delivery network. That's serverless. Amazon S3, serverless. You're only based on what you use. You're only charged on what you use. You don't have to spin up instances. So we've got a much wider world of serverless features than just functions as a service. And this really does all the way come back to abstractions. When we started off with Amazon Web Services and everything else, our focus was on automation of low-level operating primitives, compute, network, storage. Talked about as infrastructure as a service. More recently, we started talking about CAS, containers as a service, or more correctly, container orchestration as a service. Having some kind of abstraction that allows us to run containers across multiple machines. This is where sort of traditionally Kubernetes and Mesos would sort of fit in your stack. And then, of course, we have the holy grail of what most developers, I think, actually want, which is a true platform as a service. 10 years ago, this is where I thought we would all be using by now. I thought this would all be hidden away from us and we'd be dealing purely with generic, abstract platforms as a service. Things like FAS, function as a service, and BAS, backend as a service, are just subsets of that whole platform as a service. They're platform as a service building blocks for you. And this primarily is what serverless is all about. Serverless is just presenting us with better, higher-level abstractions that are not as leaky as those things that came before. Now, of course, this gets quite confusing because I've started using lots of ASs and BASs and CASs, and it gets very, very confusing when you're trying to have conversations with people about what on earth is going on. And then you suddenly, you start talking about you don't know your AS from your BAS and your CAS, and then you feel like a total ass. I'm not the only one that's taken a while to come around. Some of you may know of Kelsey Hightower. Kelsey Hightower does a fantastic job around the Kubernetes community, for example, getting everybody really excited. He's great energy, great in terms of motivating and moving the community forward. But it took him almost as long as it took me, I think, to come around to understanding what makes serverless useful. I think I'm still very much behind the curve. I now understand what serverless is. When you have a great idea, the last thing you want to do is worry about infrastructure. And that's interesting. The last thing you want to do is worry about infrastructure. This is, again, about a platform. This is about abstraction. This is about you giving up control to somebody else to provide you a higher abstracted service. If you want your fine-grained control, you do not want a serverless option. I do, though, come all the way back to that original definition. The phrase serverless doesn't mean that servers are no longer involved. It's just simply that developers no longer have to think that much about them. I'll rephrase that slightly. Serverless means you don't get to worry about servers whether you want to or not. You don't have that choice. Now, that can be a blessing or a curse, but I think it's mostly a blessing for most of us. Some of you may have heard this term undifferentiated heavy lifting before. This is a term used by Amazon early on when they were justifying why they built the sort of precursors of Amazon Web Services. This idea that they had these small autonomous teams that wanted to own their own destiny, that didn't want to have to go and raise tickets to get machines created, but equally couldn't afford to spend time racking that kit up themselves. So instead, they wrote and created tools that allowed you to automate that infrastructure, automate the process of setting these things up. But that was quite a low-level abstraction. Now, the idea of deploying my application and first spinning up a machine, then spinning up some storage and connecting it, then working out how the networks get connected, now that's so 2010. All we're doing now is we're just raising the bar of what undifferentiated heavy lifting means. That term is all about the things that are work that don't make you special. How do I get rid of that work? How do I focus on the problem at hand? And this is just 5-10 years of experience. We can do better. So it's interesting. It's just about abstractions. It's about power. But it's not some sort of magical solution. And there's still a bunch of things in serverless that give me pause for thought. Let's start by talking about this idea of resiliency and sort of high availability. So many years ago, I was working for a German investment bank in London. That German investment bank no longer exists. I'm not entirely to blame for that, but I am partly to blame. If any of you have seen the film The Big Short or read the book's very good. You may know a little thing about something called a collateralized debt obligation. That's where you take loads of bad debt and you put it all together and you go, it's now good debt. And people go, how does that work? And you say, you take all the bad debt and you put it together and then you say it's good. And then they say, I don't understand. And then you throw money at the problem and they say, yes, now I understand. It's all fine. And then you have a global financial crisis. Anyway, we didn't really understand what we were doing, but we were doing it very fast. And it was fantastic. You know, we were making somebody loads of money. It wasn't us. But, you know, anyway, we were doing these things and making magic happen. And one of the goals we had was to be able to price these sorts of special trades faster than anyone else was in the City of London. And so we were running this thing called we were using a grid pricing system, a grid system called Data Synapse. So Data Synapse was effectively like an early cluster management software that allowed you to run processes across lots and lots of different machines. And the idea was that we would be able to scale up our solution to price these things more quickly. We could basically linearly parallelize a lot of this work. And so we had this nice little grid farm that was sitting there pricing these trades, but it needed information from different sources. So we had sort of information about risk profiles coming in from Bloomberg and elsewhere. We were putting in market data feeds, and we were pricing those trades and storing them out into a database. And this is all well and good. This is fantastic. Working really well. The main reason, by the way, we were using Data Synapse was because Data Synapse had the ability to run Excel spreadsheets. So literally, we had a cloud solution for running Excel. Why would we do that? Well, very simple reason. It turns out that back then, people used to run all of this sort of risk calculation and pricing on desktop machines. And if you're a trader who wants a nice bonus, and the trade isn't coming out how you want, you just go into Excel and change a number till the number comes out correctly, and you get your bonus. People worked out that wasn't a very smart thing to be doing, so we were having to take these Excel spreadsheets off of people's machines and run them centrally. Very disturbing world. So anyway, we'd done all this, and we were feeling very good about ourselves, and then one of the people in the operations team came and said, look, you know this grid you're using, this Data Synapse product, one of the things it can do is it can actually run as a screensaver. What that means is that when people are not using their desktop machines, the screensaver kicks in and it becomes available as a worker in your grid. And he says, we've got a whole disaster recovery office just further up in North London. So all the machines are turned on, they're ready as a trading floor in case we have to evacuate this building, so we can move over with a minimal interruption in the trading day. We could just run these agents on that grid. It'd be fantastic. So it's great. We sort of turned, okay, yeah, let's roll out that screensaver. So we went from having like about 25 or 50 machines pricing these trays to having over 300 very, very quickly. And the really nice thing was Data Synapse handled this wonderfully. It just added the nodes and it grew. And so it's fantastic. And we thought, this is awesome. And so we opened up the taps, as they say, and we thought, let's see how fast we can go. And then some interesting things started to happen. We were pricing, and then, well, everything else that wasn't in the grid kind of exploded. We'd hit a classic problem of mismatched capacities. We'd basically overloaded everything that we hadn't scaled. And we have this fundamental issue that a lot of the things that we do around resiliency and things like that rely on throttling and constraints. We reduce, for example, the amount of connections that we will pass through to a database. You know, if I look at something like a standard database connection pool, this is actually partly about trying to reduce load on databases. So, you know, classically, if some requests come in, I need to get some information from the database, so I then need to go to the connection pool to get a worker to actually carry out a job, and then I can make requests. But the connection pool acts as a throttling mechanism, limiting how many connections can go downstream to that database. So we throttle that load. And if those things time out, we actually shed the load upstream. So we actually stop our process being overloaded as well, assuming we've hit the timeouts correctly. That's fantastic. The key thing to understand, of course, is for a connection pool to work, it requires persistent state of a form between requests. By definition, this throttling mechanism lives between the requests coming in. What about your functions? You're running your Lambda or Azure cloud functions. Your requests come in. As the load builds, you just add more functions. Where's your throttling mechanism here? How do you avoid the problems that we'd had with our Data Synapse grid? How do you stop all of that flood of traffic completely wiping out your database? There's no space for a connection pool in a function because it's only there for a single invocation. And so I started worrying about this, but then thinking, no, Sam, this is a theoretical problem. It's not a real problem. Maybe no one's actually having this issue. Of course, the answer to this is, well, don't use a traditional database with serverless. Use a backend as a service. So if the idea being, if you've got a huge amount of load coming in, that's fine. Dynamo will scale lovely to handle that load, and that's always the answer we get. But the question I've always got is, what about hybrid applications? If you have a non-trivial system right now, and you like the idea of using some of these serverless concepts, you're not going to just rewrite your entire system in serverless and then send it live. You're going to want to take parts of it and rework it into functions and then send it live. And so I was wondering if this was a theoretical concern I had or real, and then I met some people from Bustle. So Bustle are one of the poster children for being serverless. People say they're all serverless. They're not all serverless. They're just very successful at using a high degree of serverless stuff on AWS. They run like about 80 million uniques a month. They run a number of different news properties online. They are not fully serverless. Their backend storage tier is Redis. Whatever you think about running Redis as a database, it's worked out well for them. And they had all kinds of interesting issues. As they had more and more load come in, the functions would spin up, and those functions would routinely overwhelm and wipe out their underlying databases because they had no way of throttling those connections coming through. They ended up having to do all kinds of funky things actually down at the Redis nodes themselves to do things like shared Ethernet connections when they're overloaded to protect themselves from this. For them, moving that Redis back tier, which they put a lot of investment into, is a large undertaking, and it's not one they're willing to take. So they're constantly having to work around this in interesting ways. Let's think of another mechanism that we use routinely to defend our applications and to make them resilient. Think of something like a circuit breaker. Circuit breakers work to help us move from failing slowly to failing fast, and again to allow us to load shed. Their work is quite simple. I've got some downstream service that I need to get information from. A request comes in. I need to go and get information, in this example, from the risk service. But the risk service itself is suffering from some kind of problem. Maybe it's timing out. Maybe it's erroring too much. And the circuit breaker maintains some piece of information across multiple requests and says, look, I've had 5 timeouts from this service in the last 10 minutes. I think it's not running very well. It's not behaving correctly. So I'm actually going to pop that circuit breaker open and say, we're not going to send any requests downstream. That gives the risk service time to recover. It also means we shed load, which helps the system recover. And then hopefully when the risk service becomes healthy again, we reset it. The key thing is, again, for a circuit breaker to work, we require maintaining per client state across requests. We don't have that ability with functions, with FAS. Now, I think what we're going to end up with is some kind of middle tier to allow this stuff to be done, to allow us to throttle connections, to do traffic shaping, to do load shedding, circuit breaking, and the like. Some kind of throttling and load shedding middleware that will sit between our functions and things that aren't functions. Because at the moment, we don't have sufficient control over how these functions are invoked by the various cloud platforms to defend against these sorts of issues. Anybody here heard of service meshes? So Istio, Linkerd, things like that? Those, I think, might solve this problem. I'm not sure if that's what they're doing at the moment, though. Now, of course, I could be worrying about nothing. You know, maybe we're not all trying to build some sort of massively scalable, highly available system. And most of us, let's be honest, aren't. You know, most of us are not in this space. Most of us, we're running an application that has to handle a few hundred users. And yet, on the other hand, that's the thing that Serverless sells it on. Oh, we are highly available, we are reliable. And that's true, but it's not only have you got to be all in on their platform, you seem to have to be all in on all of their features. Let's talk a bit about security. Early on, especially with Lambda, there were a bunch of concerns raised about the security aspects of serverless and specifically function as a service. And some of those things were cited because of the use of Docker, or specifically containers. Under the hood, whether you realize it or not, functions are being run as separate containers. And there's a bit of a mantra going around the container community, which is, you know, friends don't let friends run untrusted code in containers. We know there are a bunch of different potential exploits where you can bust out of containers, gain access to the host operating system. That's why you don't typically run untrusted code in a multi-tenant fashion on the same container host. The reality, of course, is although containers are involved, you're abstracted from that. We've also got other issues, is that there's some really nice aspects from a security point of view, especially around FAS. You know, the things we start worrying about is, okay, here's my function, and there's some other malicious, evil function that's running on the same machine, and somehow that evil function is going to gain access to my function. But, of course, with FAS, if your function isn't running, it's not there. So having a targeted attack against your function is quite difficult because the malicious party would have to somehow get their function scheduled on the same machine and hope your function is running at the same time. And the reality is it's not. And you're running in a sandbox anyway. You don't get given a native container image to deploy. You are deploying a function. Amazon, in the example of AWS Lambda, are putting your function inside a sandbox anyway, giving you additional protections. I'd say all that, kinda. There is this lovely idea that if your function isn't being executed, it's not running. It's not actually true. Amazon do keep these things lying around. They do that to decrease the spin-up time when you have a second function invocation. The difference is they just don't charge you for it. The bustled team found that out the hard way. Their Redis nodes were tapping out at 10,000 connections per node. You can't run 10,000 Lambda functions at once. Back then, the limit was about 1,000. So there were 9,000 functions leaving Ethernet connections lying around. It tends not to be an issue, but it's not, there is some leakiness here. Anyway, security, I think, in general, is a good story around FAS, specifically function as a service. We are in a better place. If your code isn't running, it's hard to be attacked. And also, I think people are quite smart about keeping their functions small in scope, and code which is small in scope, by definition, has a smaller surface area. But there are other concerns people have, and this is the one I get asked about a lot. Aren't you concerned about lock-in Aren't you concerned about being stuck? I said earlier that this is all about using somebody else's abstractions. And I actually think if you're going to use them, you should embrace their abstractions rather than trying to work around it. But then that means I'm stuck, I'm locked in. And part of the reason that people are concerned about lock-in in the context of cloud services is because we still sort of have this worry, and this thought in our heads that, you know what, cloud should be utility, shouldn't it? I should just be able to switch provider at whim. Like I can just click a button and now I'm running on Google, or I can click a button and now I'm running on Azure. And that was what we were originally promised, that cloud computing was going to be utility. And it's rubbish. Utility requires very simple abstractions, and we don't have those very simple abstractions. Do you know what utility is? In the UK, I can go to a web page, I can type in my address, and click a button, compare all the electricity prices, click another button, and switch provider, and it is completely transparent to me. I don't have to recable my house. I don't have to change the plugs. That's utility. If you think about it, sure, once I spin up a machine on Google and spin up on an Amazon, they look kind of the same, but the whole process of running that thing in the first place is quite different on both those platforms. We have to accept we don't really live in a world where we have true utility of most of the cloud services we have. So what does that mean? Well, get over yourselves, partly, right? You probably don't need to be cloud agnostic for your project. And switch your thinking. Don't think about lock-in of any cloud services. Think instead about migration cost. If you're going to use something from AWS, from Google, from Microsoft, think of that. Look at that product you're using in isolation. Look at S3, look at EC2, look at Azure Cloud Functions, and think about if I chose to move this to another platform later on, how much work would it be? Because this makes it much easier for you to have a rational conversation about this stuff. You know, for example, if I think about moving something like blob storage, like S3, so I've got a whole lot of data on S3, moving that over to a similar service on Azure is not that much pain. It's just really about exporting and re-importing the data. But the abstraction itself is simple enough that moving it over is not much work. Compute is painful, but again, once you spun the machine up, everything else should act more or less the same. Load balancers are quite easy to port. I could easily replace an ELB on Amazon, for example, with my own software-based load balancer. It's work, but it's doable. You then start getting into products that are being offered by the cloud vendor, which are very hard to reproduce, where the semantics are quite hard to get somewhere else. Do we have portability of functions between the different fast offerings? No. Even worse is actually the backends, the databases. It's very hard. You can't reproduce the semantics of DynamoDB anywhere else other than on AWS. And so typically, if you want to move to a different platform and you're using DynamoDB right now, you're going to have to probably rewrite aspects of your application in order to use some other form of storage. So that's going to have additional costs. And this can actually start helping you making rational judgments about how much you embrace a platform. Because here's the trade-off. The trade-off is really between pay now or pay later. If I use this awesome feature that comes from my cloud vendor, it's just great. I get to use it right now. We get the benefits right now. Later on, I might regret that decision. The alternative is sort of tying yourselves in knots by saying, oh, well, we don't want to be locked in to this service. Let's create some abstraction layer. When you do those sorts of things, you pay the cost of the abstraction now, and you hope you might get the benefit. But if you create some abstraction over the cloud service and never switch vendors, that is wasted money. This is what it all comes down to. So when we talk about things like FAS especially, people say, should we mix vendors? In general, I say no for a given solution, for a given system or application. Mixing vendors is problematic because you've got a whole load of different skill sets you've got to take on board. You know, knowing AWS really well isn't the same thing as knowing Azure really well. You also have all kinds of issues around latencies when you're cutting across different cloud vendors. Now, across an organization, you may absolutely want a bit of a mixed strategy. You may well want to say, look, this team over here, they're using Azure, and we're really, really excited by what they can do with it. This team over here is using AWS. Therefore, as an organization, we've got both sets of skills. We're hedging our risk at a corporate level, at a larger organizational level. I think it's very hard to justify mixing vendors sort of at the team level, because you just end up spending all your time just having to double up the amount of skills you've got to learn. And we should also remember that sometimes being locked in isn't so bad. We often have some of you have probably heard the phrase walled garden. And walled garden is typically used in a bad sense. Oh, you're stuck with Apple. You're in the Apple walled garden. And there's all these people, like Android people, telling me how terrible it must be for me to be stuck in the Apple walled garden. I'm like, my walled garden's awesome. It's really nice. Like, people bring you drinks, you're nice near the next nice babbling brook. I can walk around the garden. Yeah, it's high walls. It's quite painful to get out. But inside the walled garden is pretty nice. So maybe you're stuck with your vendor. Maybe you're all in on the platform. But that means you get to really take advantage of what it offers. And if it's a great platform and a great place to be, that might be totally okay. So, I've gone through this journey over the last couple of years trying to make sense of all of this stuff. I've talked to lots of people about serverless and how they're using it. And a lot of the same concerns, they haven't really changed for me in a way. The concerns about resiliency, for example, are still there. The concerns around hybrid are still there. I'm not seeing enough case studies of people coming forward and talking about how they're using serverless in a hybrid way. What I'm seeing are lots of people saying, oh, look, we rewrote everything in serverless and look how much money we saved. The world isn't that straightforward, I don't think. I think what is exciting is this idea that we're getting closer to good abstractions over how we build and manage our applications. We're in an interesting world. When I first started, I was quite lucky when I first started computing. Just a few years later, Agile came around and everyone got quite excited. And it took about 15, 20 years for that term to be completely and utterly devalued. But it happened, right? But we still, have some rough idea what Agile is. We had DevOps, and it took DevOps about a year before the term was completely meaningless to lots of people. There are still people out there that say, I want 15 DevOps stat, like DevOps is a noun. I need 5 DevOpses to do the DevOpsing on this project over here. I'm going to do the DevOpsing by buying this tool chain from IBM. I just don't know what that means, right? So it didn't hold its definition for very long. We have microservices, an even more hyped term, arguably, than DevOps. That held its value for about 6 months. Serverless seems to have gone into meaningless even before it was even used. I do want you to think it's not really about the term. It's more about the patterns of behavior that it allows us to adopt. It's more about freeing ourselves to think of the problem at hand. And think about that. Think about those abstractions. Abstractions give you power. Don't be sucked into thinking that you can't use something just because it's not serverless. The reality is, there is no future where there are going to be fewer servers, where there are going to be fewer computers. But we're growing the number of computers far quicker than we're growing the number of developers. So we need those abstractions. We need abilities and means to access the power of all of those computers without having to get as involved with the detail. I think it's interesting. I spend a lot of my time looking at container and container-related technology. I think stuff like Kubernetes is really exciting. I also think it's going to become a bit of a meaningless detail to most people within 5 years. I think most of us will be using platforms that sit on top of things like Kubernetes. We won't be dealing with containers anymore. And this is just experience. We're just better at coming up with these non-leaky abstractions. And that, for me, really is what serverless is all about. Can I identify that undifferentiated heavy lifting? Can I identify those aspects of my working life that aren't important to what I do? And can I find a platform out there that does this stuff for me? So I am still confused, but maybe slightly more enlightened, but I'm not getting any younger. But I hope this was at least useful for you. We do have some time for questions. There's a question at the front. We have a microphone, and a helpful person is bringing the microphone. Up here. Oh, there was someone. Okay. We'll get to you in a minute. We'll do this person here first. So, go ahead.
Hi, thank you for a very thoughtful presentation, and 2 questions. First question, is serverless actually what people used to understand by stateless 10 years ago, and so it is just more generic term? And second question is about the scalability limits. For example, on the backend side, we already have such meanings like data locality and things like DynamoDB. They provide partitioning. And for example, if I have a business logic split across 100 functions, for example, and data are stored in one partition, how will they worry about how these functions are executed? Are they executed in the closed space or distributed across the world?
Okay,
thank you.
So the first things first, is serverless stateless? Absolutely not. It's just about not dealing with servers. S3 is an incredibly durable blob store. By definition, is a stateful service. I store my state in it. Backends as a service. So no, it's not stateless. Functions as a service promote the concept of stateless functions, but statelessness and serverless do not go together. There's value in both things. The second thing is you start talking about all these different ways you can scale your application and how you might want to tweak things. You don't get any of that power right now. None of that's there. What you're doing is you're relying on the underlying platform provider to kind of do the right thing for you, and at the moment they don't give you many dials and knobs that you can tweak. And this is always the fundamental challenge with any sort of serverless type technology, which is you're relying on the vendor that you're using, sort of configuring the system in such a way that it suits your use case. Now, if your use case is quite typical to the other kinds of customers that use that platform, chances are the default behavior will work well for you. But I've certainly worked with cloud platforms before where the particular use case I was in didn't suit how the vendor had created that product. So I used a very early PaaS from Rackspace many years ago that was designed to help you transparently scale your PHP application. And we were working with a particular client, and this client was creating training software. So the idea is that you would have a classroom, you'd get 100 people into a hotel classroom, and they'd start some certification course. And so you had 100 people would log onto the website at the same time. And it just fell over in a heap every single time. Because what happened was, Rackspace saw this thing never being used, then suddenly 100 people hit it all at once, and they never scaled it up quickly enough. And they didn't expose any ability for you to pre-warm it or anything else like this. If any of you have ever done load testing on AWS before, you may remember back when you'd have to phone Amazon up and say, look, we're going to do some load tests. Can you pre-warm our ELBs so that we get production-like comparisons up? So this is the issue with any of these things. It's going to be down to how good is their tuning for the default case and what things they give you in terms of controls to give a bit more fidelity over what actually happens. It will be interesting to see how many of those things get added. I think ultimately, of course, their answer would be if you need that level of control, maybe you run these things yourselves where you can get that control. And then I'm sort of looking for people to be providing frameworks that give you things like function as a service on top of Kubernetes, which might give you a lot more ability to control how those things are executed. But of course, then you've got to run that kube cluster yourself. Cool. I think we had a question at the front.
Hello.
Hi.
Thank you very much for your presentation. It was a nice glimpse in the future and was really exciting to listen to.
Thank you.
So my question is concerned your concept of serverless technology of platform as a service. So we all have an idea what kind of services are function as a service, backend as a service. Could you please share your vision? What do you think, in more technical, specific way, platform as a service is?
I think so. For me, it's For me, platform as a service is serverless in a way. Like it's a higher level abstraction. I just think about my application. I'm thinking about the building blocks of my application. I want to get as far away from all the detail. So for me, serverless is almost synonymous. It's the same thing as what I always thought PaaS should be. I think our early platforms as a service were a real mixed bag. It was really interesting if you look at all the early platforms as a service that tried to do away with the concept of a server. They all struggled. Heroku did well because they accepted that people want a bit of fine control and that they couldn't configure these things for the generic case. But you look at things like Google App Engine, the Rackspace, PaaS that I mentioned. I think all that we've done now is we've got 10, 15 years of experience of building these things. And so for me, it's the same thing. PaaS is just serverless. Serverless is PaaS. And I think we're already in a world where we have loads of building blocks of how we think about our applications that we can pull together that are serverless. We have queues that where we're not running the queue, we just say, I need a topic, and the topic is there. We have storage, we have network. And so that for me is just, if anything, this is just sort of getting us much closer to what I always hoped we'd have 15 years ago. Whether or not the solutions that we're getting now are going to solve everybody's problems, I doubt it. The question is it going to solve 95% of the problems that most of us have, or is it going to solve 20% of the problems that most of us have? I think it might be closer to 20% than the 90%, but even that is better than 0%. So I hope that kind of makes some sense. I've probably got time for another question. One more question here. Go ahead.
In addition to my question, maybe you can give some examples of how we can interact with it.
How do you mean interact? What examples of how we can use serverless?
Yeah.
There's lots of different ways. I mean, I think it's more to think about. So here's my default position now is if I'm building a microservice architecture is I'm actually, if the team I'm working with is already on a cloud platform, I actually have inverted my thinking. I'm not thinking where should we be using some serverless feature? I'm actually flicking my brain around to say why can't we? So if all I've got is I've got an HTTP request that's coming in and I need to fetch some information out of a data source and return it, that can just be a function. I'm not thinking about a running service anymore. So I'm really trying to switch my brain around the other way to say, why couldn't I be using some kind of serverless offering? But I think where I'm more struggling with is the hybrid examples. So yeah, I think it's applicable for a whole range of different problem spaces. I think there's some particular ways that people like solving problems where it doesn't fit. There are, things like distributed actor-based clusters, which by definition are stateful, long-running services. It's not going to fit those types of models. But yeah, for so many different types of applications, I think it works really, really well. So I think it's more where couldn't I use it rather than where I could use it. Cool. Maybe one more question. One more question over there on the side. Let's see how quickly. We've got two people running towards them. Oh, we're going to have a race. That would have been fun. Okay, all right.
Hello. Okay. So last question was about examples where we should use serverless. And I want to know your opinion. Maybe you give some examples where we shouldn't use serverless.
Where shouldn't you use serverless? I think where you need fine degrees of control. So I think the gentleman earlier was asking, well, what if I've got this type of situation, where I've got that type of situation? I think organizations so I think the key thing is I still have some of those concerned about spinning things up quickly enough for you. A bunch of the serverless stuff out there, I mean, Dynamo certainly suffers from problems. I know a number of clients that have ditched Dynamo because for them and their use cases, it wasn't scaling appropriately in terms of handling the throughput they wanted to, which is then they'd invest in things like Cassandra and stuff like that. So certainly because these things, in terms of how they scale up and scale down, are tuned for the generic case, and you have limited control, they may not fit things if your organization or your load patterns are a bit more of an outlier. So, you know, in those situations, it's always something you're going to have to actually test for your particular workload. And so those are the sorts of areas where I would be wary. The problem is, of course, is it's hard to know until you actually try it out. So I would always say, you know, doing some kind of spike to look at how that load will scale up or scale down. Again, the concerns I raised around those hybrid type applications, you know, having one part of your system that theoretically infinitely scales, although scales to like 1,000 invocations, and having that being able to sort of expand out, and other parts of the system not being able to expand out in the same way, that's going to give me pause for thought. Ultimately, someone like the bustled team, they just had to live with that and just dealt with it actually in their database tier and had to do all kinds of funky things to deal with those sorts of problems. So yeah, I would say, you know, if you've got very peaky loads, you definitely at least suggest doing some tests. Yeah, I think you actually need to test your vendor as well. Cool, I think we're at time now. I'm going to leave you to go walk the halls and get ready for whiskey, although we are having, there's one more talk in here after.
Yeah, we have one more talk after a little break. So thanks a lot for your talk.
Thank you.